Welcome to The Explainer. Today, we're diving into the tiny digital brains that power pretty much everything around us, from your toaster to your laptop. Now, you might think a processor is just a processor, but it turns out their internal designs are worlds apart. Let's get into why that is.
So let's kick things off with a little puzzle. Think about a TV remote and a super powerful laptop. I mean, they couldn't be more different, right? One does just a handful of simple things, and the other can, well, do just about anything. But they actually share a really important common ancestor. And here it is. They both have a brain on a chip that's running the whole show. The thing is, the brain in your remote is a totally different beast from the one in your laptop. One's a highly focused specialist, while the other is a powerful, do-it-all generalist.
Okay, so here's the absolute key difference. A microcontroller, or what we call an MCU, is basically a self-contained system. It's got the processor, the memory, everything it needs all packed onto one single chip. A microprocessor, or MPU, on the other hand, well, that's just the processor. It's the powerful brain for sure, but it can't do a single thing without a whole support system of other parts.
First up, let's get to know the microcontroller. You can think of this one as the super efficient, totally self-sufficient specialist. It's designed to do one specific job and do it absolutely perfectly.
So an MCU is really just a tiny, dedicated computer on a single chip. Its whole purpose in life is to control one specific task inside a bigger device. That's what we call an embedded system. You're not going to find an MCU running a web browser. You're going to find it running your microwave, your car's braking system, or maybe a smart light bulb.
And see, this all-in-one design is what makes it a complete system. Along with its CPU brain, it's got memory built right in, RAM for its working memory and ROM to hold the permanent instructions. But what's really crucial is that it also has its own input and output ports built in, so it can talk directly to things like sensors and buttons all by itself. You know, a great way to think about it is like a Swiss Army knife. It might not have the absolute best knife or the world's greatest screwdriver, but it's got all the tools it needs packed into one tiny package, ready to go for a specific set of jobs. That's the microcontroller in a nutshell, an all-in-one, purpose-built tool. All right, so now let's meet our second character, the microprocessor. If the microcontroller is the specialist, then the MPU is the incredibly powerful, but kinda needy, generalist. Now, the microprocessor, or MPU, is what most of us are actually thinking of when we say CPU. It's the core brain of a computer, and this is a huge but, that's all it is. It is completely dependent on external parts. Separate chips for memory, for handling inputs and outputs, you name it. It simply cannot function alone.
So if you look inside an MPU, you find all these core elements for pure computation. The arithmetic logic unit that does the math, the control unit that directs traffic, all that good stuff. But hey, notice what's missing compared to the MCU. There's no general RAM, no permanent storage for programs, no built-in I/O. All of that has to be added on the outside, on the motherboard.
And the perfect analogy here is a world-class chef's knife. It's an amazing tool, right? Unbelievably precise and powerful, but by itself, it's just a piece of metal. It needs a whole kitchen around it, the cutting board, the ingredients, the stove, to actually make a meal. The microprocessor is that knife. The rest of the computer is its kitchen.
Okay, but the differences don't just stop with what's on the chip. The actual internal blueprint, the way they're wired to access information, is fundamentally different. And this design choice completely changes how they think and what kinds of tasks they're good at.
Microcontrollers usually use what's called the Harvard architecture. I want you to imagine two separate highways going to the processor. One is only for instructions, what to do, and the other is only for data, what to do it with. Because these paths are totally separate, the MCU can grab both at the same time, which makes it super efficient for simple, real-time tasks.
Microprocessors, on the other hand, typically use the von Neumann architecture. Now, in this case, there's just one main highway for both instructions and data. So while it can't technically grab both at the exact same instant, this unified memory space is way more flexible. It lets the processor treat instructions as if they were data, which is a key trick for running complex things like operating systems.
So with these two completely different design philosophies, how does an engineer decide which one to use? Well, it really all comes down to picking the right brain for the job.
The trade-offs get really, really clear when you see them laid out like this. When it comes to cost and how much power they use, the MCU is the clear winner. It's cheap and just sips electricity, which is perfect for anything running on a battery. But for raw power, the MPU is in a completely different league, with speeds measured in gigahertz, not megahertz.
This is exactly why an MCU is running your washing machine, but an MPU is powering your laptop.
And that's honestly the most important thing to take away from all this. It's never a question of which one is better. A powerhouse microprocessor would be a total waste of money and energy in a TV remote. And a little microcontroller would be hopelessly, laughably underpowered to run your computer. They're just different tools, each one perfected for its own job. So we'll leave you with a little challenge. As you go about your day, take a look at the smart devices all around you, your coffee maker, your car dashboard, your fitness tracker, and just ask yourself, what kind of brain is running things in there? Is it a self-contained specialist or a powerful generalist? You'll start seeing this hidden digital world absolutely everywhere.